welcome everyone to the Plugged In podcast with your host today, Matthew Langstaff, and our great guest, Dr. John Warner, Chief Customer Officer at American Battery Solutions. How are you today, sir? Are you well?
I'm doing well, Matthew. Thank you. How are you?
I'm doing very well indeed, thank you. Yeah, and listen, thanks for joining the podcast today. We're really looking forward to having you on the show, getting some insights into ABS and all the great work that's happening across the business, and your journey there as well, really, and the impact you've had on the team. So great. Yeah, listen, I think what we'll do, John, as we kick things off, we'll start at the beginning, right? So, what market gap did ABS set out to fill in that 2018, and how did your founders see the battery space evolving?
Yeah, that's a really great question. So, we started the company in it was actually the fall of 2018, the summer of 2018. Subhash Dar is our CEO, and he's the founder. He pulled together a group of about 10 or 12 of us. And he was kind of exploring opportunities with various partners. And we had an opportunity kind of presented to us by an investor group that he was familiar with. They said, "Hey, listen, we want to make some investment in this kind of green energy space. What would you recommend?" And so it really was an exciting opportunity for us to say, "Hey, look, this is what we would do if we were starting up a new company." And they said, "Awesome, do it." So as we kind of presented the idea, we said, "Well, what have we seen? We've been in the industry for, at that point, 10 or 15 years, and Subhash been in the industry since the early 1980s. So what have we seen? What do we think would make sense for us?" And especially in 2018, 2019, what we saw is there was a lot of companies which had smaller volume applications. Think of delivery trucks, school buses, transit buses, kind of the work trucks, right? They don't have automotive volumes. They're not selling 250,000 vehicles a year, right? They're not hitting Tesla volumes, but they still need an automotive quality battery that's manufactured to high quality systems and validated to all those same performance specs. And the problem was, especially in 2018, 2019, the biggest cell makers said, "Well, this isn't big enough for us," right? So they were looking at it saying, "Hey, listen, I want that $1 billion automotive program, right? I'm not worried about a small bus project." Yeah. So we said, "You know what? This is a great niche for us. Why don't we focus on this?" And again, we're all out of mid central Detroit area here, right? So we're mid-Michigan people here, grew up in the auto industry. So we know things that roll. We know cars, we know transportation applications. So it was a natural place for us. So we said, we're going to focus on this, and we're going to try to keep ourselves, really laser targeted on what we do. So we really focused on, I like to say things that roll, float, and fly, but really just things that roll initially. We look at things in the aviation space and we look at things in the marine space, but those are more future applications. We focused on things that were non-automotive because all the OEMs are doing their own battery packs, right? So if you're a General Motors or a Ford or a BMW or a Volkswagen, your volumes are so big that you need to integrate just from a cost saving standpoint to do your own packs. So we said, well, let's not try to get into that side of the market. Let's focus on these applications where there's going to be lower volumes, but they still have the same high needs. So that was kind of the whole impetus for the company. Let's select a strategic market that has a high need, and let's focus all our efforts on that.
Nice. I think it's key, isn't it? Identifying that niche right at the very beginning, and that kind of sets off your roadmap right from the get-go. So, no, I fully get that. So, again, kind of focusing it on the beginning. How did the acquisition of those Bosch facilities in you mentioned Michigan? Obviously, I know there was one in Ohio, I believe, as well. How did that position you competitively within that market?
We as we look back on it today, and even then, we knew that probably gave us a 5-year jump start. Right. So starting up a brand new company, you're starting with nothing. We love to tell the story. We started the company renting a conference room in a hotel in downtown Pontiac, Michigan. Right. And that was that was essentially there was 12 of us in this little conference room, and that was it. So it's like, okay, how do you go from there to manufacturing? And we got really,
it's quite the leap.
Again,
that's quite the jump, isn't it?
So how do you do that? And other companies have had similar challenges, but we got very lucky. Like I say, sometimes when you think of starting a company, sometimes it's like dominoes falling. The investor engaging with us, the acquisition of the 2 assets from Bosch Battery Systems was due to a phone call, right? So Subhash, our CEO, had a very good relationship with the gentleman who at the time was president of Bosch Battery Systems. And they were getting ready to change their strategic focus, right? So they were moving out of the high voltage batteries and focusing on kind of stop-start batteries. So they had these two facilities that we really don't need them anymore. So we wanted to sell them. And so they called up Subash and said, hey, listen, we know you know a lot of investors. Can you introduce us to some? We want to sell some of these assets. And Subash said, well, what are you trying to sell? And again, it just started the chain rolling there. So, well, we've got this manufacturing facility down in Ohio. And he says, well, that's great, but I also need an engineering center. He says, well, we've got this facility in Lake Orion, Michigan. So we bundled the two together, and we initially took over about a third of the engineering facility in Michigan, and then later we took over the rest of the facility. So really, it gave us a manufacturing facility, which was a big jump for our investors, right? We were years away from making production parts. But we knew we would need the infrastructure. We knew we would need it. And if we didn't take it now, it would be more expensive to get it later. So our investors were really, really supportive of us. They helped us get in there. They supported the idea to get the plant, 170,000 square foot in Springboro, Ohio, Southwest Ohio. Fabulous facility, fabulous area to manufacture, and right in the heart of the Midwest. And then here in mid-Michigan, in Lake Orion, Michigan, so we're about an hour north of Detroit, we've got this engineering center, and we've taken over the entire facility now. So it's 120,000 square feet of engineering development, test and validation with power coming into the facility. We had test services or test devices already in place. So we had, I don't know, about 200 channels of cell and module testing and pack testing on site. We've more than doubled that since we've got it. So we've got amazing facilities here, and we've now got two low volume prototype lines, as well as over 400 channels of cell testing, 50 or 60 channels of module testing, 50 or 60 channels of pack testing. So we do about 80% of our own validation right here in house.
Yeah, and I suppose, like, what, because you were there at the beginning, right? I
Yeah.
mean, what's it like to reflect on that time? I mean, going back to that conference room in hotels, and to where you are now. I mean, it's some journey that to kind of look back on and reflect on, right?
It really is. It really is. It's exciting. Anytime you're in kind of that startup environment, there's a lot of excitement there. There's a lot of passion. Everybody is really, really passionate about what you're doing. And it's just really interesting to see the company evolve over the years from kind of, that dozen people that we started with, to 350 or 380 people. I think we're 384 people last I checked, in two facilities, and continue to grow. So watching that and thinking about that, we got really lucky, I will say. If you look at some of the battery pack makers in the industry, some of them weren't as fortunate as we are. Their investors didn't last as long.
Sure.
And we got really lucky. When it came time to expand, and this is, I've had some long discussions with other people in the industry, and I'll actually be speaking at the battery show on this topic. But there comes a point when a young startup company's got to make that next growth leap. They've got to actually have that next several $100 million investment for OpEx and CapEx, right? And that's kind of where we were at. We were engaged with the DOE for a long time, trying to get a loan from the LPO office. We looked at 2 or 3 other potential investors before we were really, really fortunate to have an opportunity to join the Komatsu family. And so, now we're a wholly owned subsidiary of Komatsu. That has been a blessing for us, not only from helping to fund our CapEx expansion that we needed to meet, customer demand. We actually had purchase orders we were trying to fill, but also looking at our continued growth as we go and move towards a profitable company. So having a partner like that who understands and thinks of us as a long-term vision rather than a short-term, put some money in and get it out a year later, right? So we had a company who was really, really a really long-term visionary company in Komatsu.
Yeah, great. The faith's been rewarded, right? And it's a risk, isn't it? You've really got to, it's challenging navigating those markets, and we'll come to that again, later. Navigating the more kind of challenging markets for the tariffs and things like that. But it is that risky business, and you do need someone to kind of take that leap of faith with you. But yeah, look, I mean, looking back to kind of 2019 to now, I mean, what kind of key moments would you say has reshaped that business model?
Yeah, so that's a really good question. So I would say a couple of things happened. 2020 hit. We all know 2020 was an exciting year for the world, right?
Sure.
So COVID hit. Again, we were less than a year old, I think, when COVID actually hit, or just about a year old. So we were number one. That shaped a lot of what we were doing. Interestingly enough, we were sitting here, and it seems like when COVID hit, all of the OEMs suddenly had time. They're all sitting at home. They had time to start writing RFQs. So we actually got deluged with RFQs for 6 months there. So we were working, my compatriot in arms here, and I were working until 10 o'clock every night, just trying to get RFQs put together. From home, right? Working all this stuff together, trying to put these together. So we actually won, and I would say this is really our two milestones. And this is the other thing that I think really is key to our success. But we won our two largest customers during 2020, believe it or not, without ever meeting them in person.
That's no mean
feat. Oh my gosh, it was a lot of work. It was a lot of back and forth, a lot of Teams calls, a lot of proposal revisions. But we won. The first one was New Flyer Industries. So we've already publicly announced New Flyer. So we are now one of their battery suppliers. They have two suppliers, and we're ramping up. So we did, we've done hundreds of buses for them now in the last year and a half, and continue to grow with them as they grow. Looking for more opportunities to expand with them. But that project is going well. They're a fabulous partner in the industry. New Flyer is really doing amazing stuff. They've been electrifying vehicles for a long time. And there's still a lot of demand for electrification in the transit bus industry. So we're seeing that here, the big cities, the Bostons and New Yorks, the Miamis, Torontos, all these big cities, they're electrifying heavily right now.
Yeah.
And the other one we haven't been able to publicly announce, but there's a last mile delivery van program that we were awarded about the same time as New Flyer. Within about a month, we got both of them. So those really started us off, I think, and those were really the two big milestones. And then, of course, it took us a little longer to develop both products, really as a result of the COVID. And that's why I say COVID was important, because I think we would have been a year sooner to market with both if COVID had not hit, because as the supply chain started getting rough, and as cell supply started getting in low demand, things that we were expecting to get done just took a lot longer to get done. So it took us probably a year longer to get into production with both customers than we had initially planned. But both of them are running in production today and running very well. And so those kind of led us to drive our product development and our product philosophies, and get the manufacturing lines up and running. So
yeah. I think navigating through that complexity is a really interesting subject, isn't it? I guess you become stronger for it, really. There's a lot of lessons to learn from that challenging period, and some great customers to kind of come through it as well. So
absolutely.
That's fantastic. And then, so you obviously serve diverse sectors as well, in the industrial and the commercial markets. I mean, how do you manage engineering that bandwidth while still innovating so quickly? Because you guys are innovating incredibly fast, so it's obviously very difficult to kind of manage and spin both those plates at once. How do you manage to do that?
Well, it's a really good question. So, I will say we've got a fabulous engineering team. We've got a fabulous team who's really working on product development. And what we did is, when we sat down and decided, we were going to start this architecture, and that was, I say, where we differentiate, is we developed an architecture. We didn't develop a single module we were going to try to spread across everything. What we did is we developed an architecture that we could scale. And it scales in a couple of different ways. We've designed and developed and validated 3 different modules with different series and parallel connections. So we've got different electrical configurations you can put together. So you've got these 3 modules already validated, but you can also put them together in different series configurations, right? So I could do my off-the-shelf product uses 6 modules. But I can do from a 4-module pack at 240 volts to a 11-module pack at 650 volts, or a 12-module pack. So all I'm doing is connecting them in series, and just like 13 part numbers have to change, right? So it's not a no change, right? There's still got to be some tooling and that kind of stuff, but it's a really easy expansion to be able to say I need to do a 6-module, 7-module. Or whatever configuration we've needed to do. And so that's really what I think has allowed us to do that, to meet some of those customers' needs in some of these diverse markets. So if you look at some of the stuff we're doing, we developed this 350 volt, 52 kilowatt hour off the shelf pack. Some of our customers said, this is great, but I really need a higher voltage. So we were able to very quickly make some adjustments and make it a 700 volt pack. So now what we did is actually series 2 packs together. Same module, right? So all you're doing is instead of running 6 modules in series, I'm running 12 modules in series, but in 2 boxes. So relatively easy change. And so now I've got a 700 volt, 100 kilowatt hour, subset of 2 packs, which you can then parallel. So you've got this ability to parallel these packs. I can parallel up to 10 packs. So I could do philosophically up to a megawatt hour. And that means that depending on, what vehicle OEM you're going into or what application, you can use one set at 50 kilowatt hours, or you can use the series set at 100 kilowatt hours, and use as many of them as you need for different vehicles. So, one of our partners, Tico, which is a yard truck manufacturer, right? So they use either 100, 200, or 312 kilowatt hour systems. Basically, it's 1, 2, or 3 sets. So depending on the customer they're going into and the duty cycle, they can decide how much energy they put in it. So you're not locked into a single one. So it's really that modularity we designed into it and that flexibility with the system. So we can customize them, right? So we can take those and we can do different S&P configurations. Takes a little bit longer, a little bit more work, but we've got the architecture here. So that was really what it was all about. We based it on a 2170 cell. And so it's how can we quickly adjust that architecture? So that was really what our whole philosophy. Let's develop an architecture that we can use in industrial applications. We could potentially use them in forklifts. We're using them in these work trucks. We're using them in everything. Actually, if you go all the way down to our smallest product, we make a 3 kilowatt hour module, which is either 24 or 48 volts in a lead acid form factor. But if you look at the way those cells are connected, they're connected exactly the same way we do it in our 100 kilowatt hour or 110 kilowatt hour pack or our 50 kilowatt hour pack. So the cell architecture is the same for all of the systems.
I think that's the secret, really, isn't it? It's about being adaptable. Having a product that is great and sings, but can be adaptable to many different kind of outlets. Right. It's probably the key to success, really, and it's having that that core product, but making it so adaptable and flexible to all kinds of different things.
Absolutely.
So that's a really interesting point you've made there. So I guess what is that's driving your strategic direction then at the moment?
Well, we talk to a lot of customers. And so we really focus on what are the customer needs. I think that's ultimately what it comes down to. So look at how technology is developing, look at what the customer needs are. So we're kicking off right now. We're in the midst of working on our next generation of products. So we did a strong survey looking at what the market needs, look at what our market needs, right? So we know there's other markets out there. There's ESS happening, there's stationary systems, there's aviation, there's stuff. But if we look at the mobility applications, and they call it the ground mobility applications, we said, where can we go and how do we expand our portfolio? So we're not necessarily going to replace our existing portfolio because we've got a lot of flexibility in what we do today, but how do we add something new to our portfolio? And one of the things that we looked at was, okay, we know one of the challenges we have with our product is we designed it to fit with an 850 millimeter frame rail. So let's make a narrower version of it, right? So now we're going to focus on a 630 millimeter wide pack. So now we can fit under some of those narrower frame rails. So we started looking at what were some of those needs. So we can probably increase the height a little bit. We probably got some length in some of these packs. But we said, let's look at the cells that are out there as well. What's happening in the cell world? We use an NMC today, or NMCA cell from one of the leading Korean makers. But we said, what else is out there? And you're seeing a lot of focus on 4695 cells right now. So we were able to find several 4695 manufacturers who had available capacity and were willing to engage us in getting supply agreements in place. So now we're looking at a next-gen architecture, which will arguably be a simpler architecture. We're going to take a 4695 that allows us to do more of a cell-to-pack type architecture. It's going to be narrower. It's also going to be a flatter pack. So now I'm going to have called a low profile pack as well. But it's going to have that same ability to parallel packs together. It's going to start at a 700 volt, 113 kilowatt hour building block. And then we'll be able to parallel those together to create larger systems as necessary, with still having that scalability to be able to change the series in parallel for different applications as needed. Yeah. So that it's still a few years out, but we're working on that. We're looking at some things like potentially adding a wireless BMS architecture to it. Adding some other functionality to it to help improve the user experience as it gets integrated into those vehicles.
Brilliant. Yeah. Now I'm going to take you to 2023, John, the Komatsu acquisition, right? And it's an interesting time period, right? Especially for your development, because I wanted to kind of dive into that because I was interested to find out about the operational or the strategic doors that opened from that acquisition for yourself and how that impacted the business.
Yeah, one of the challenges I think that any young startup has is just the fact that you're a young startup, right? You don't have 100 years of manufacturing here. You don't have 100 years of quality experience, right? So, the first things that we were able to really do was we engaged with the Komatsu engineering team, the quality team, and the manufacturing teams. And it's like, listen, here's what we put in place. Come in. You've been manufacturing stuff for 100 years. Come in and tell us how we can do it better.
Yeah.
And they were great partners. They've been great partners all along the way. They've come in and help us run design of experiments, run different tests, and say, you know what, if you did this just a little differently, you can get better efficiency on the equipment. And so really improved our safety, improved our quality, improved the overall manufacturing performance. At the same time, engaged with the Komatsu engineering team. And Komatsu has got some very important strategic targets of reducing their global CO2 emissions by 50% of their 2010 levels by 2030. Huge target. And then net zero by 2050. And so, they know they're going to need a portfolio of electrified solutions. That doesn't mean necessarily everything's going to be electric. They're going to have some hybrid solutions. They may have some fuel cell solutions. So we've engaged with them and start looking at, okay, how do we create a architecture? How do we use what we've got today to help support some of your growth? And then how do we look at our next gen stuff? So the next gen architecture we talked about is also going to be shared with some of the Komatsu. So we use it both for the commercial vehicle space and for some of the Komatsu mining and construction vehicle applications. So we'll get some of the cost savings from some of these future architectures and be able to put those together. But it's been really amazing to be able to look at the processes they put in place. Again, you've got a lot of well thought out processes, and so we engage with them, and we meet with the leadership at Komatsu 2 or 3 times a year, and we look at our process and how we're doing there. And of course, from a financial standpoint, I think it makes ABS a stronger partner when we talk to our suppliers and when we talk to our customers, having somebody like Komatsu that is standing behind us.
Yeah, having someone like that in your corner is priceless, isn't it? Really,
absolutely.
It really is.
Absolutely. Yeah. And so that's really been priceless for us. I think that's been an amazing benefit of having a partner like Komatsu. So our manufacturing team has had huge impacts. Our quality has had huge improvements. Our engineering team is engaged looking at it globally. And we've started to adopt some of the global policies, right? So Komatsu is not intending to come in and take over, but they're sharing the things that make best practice sense, right? So we're looking at things like HR policies and corporate policies and say, yes, absolutely, these make sense. Let's adopt some of those. The way we do financial reporting, we've restructured our financial reporting so we follow their financial year and then some of the reporting procedures. So those are the types of things which were bound to happen when you go through an acquisition like that.
Absolutely.
But it's improved, I would say, all of our processes and systems throughout the company. They're a phenomenal partner to have. Really fortunate.
Yeah, absolutely. Now, I think that leads us nicely onto product lines, right? Let's start talking product lines, because where does ABS stand today between like off the shelf versus your kind of custom battery system?
Well, and it's important. So we talked about having an architecture earlier, right? So because we've got those architectures, we've developed a couple of off-the-shelf families because we know that not every customer has the resources to fund their own development program, right? Especially the smaller customers. A lot of them are out there just don't have those resources. So we know that there's a market out there for this kind of off-the-shelf family. So we created 2 families of products. The one we call the Alliance, which is kind of the alliance between the battery pack makers and the cell makers and the customers. That was kind of where the nomenclature came from for the Alliance. And obviously Li in there from lithium ion, right? But that's our low voltage family. So that's a 24 and a 48 volt. It's a lead acid replacement. It was just initially designed for golf carts and those types of light electric vehicles. We've got a great partner with Metalcraft who is hybridizing some of their commercial lawnmowers with it and are expanding into their product lines. It's being used in several of the heavy-duty truck makers, Class 8 truck makers, to power their housing loads. So, we're getting a lot of interest and demand for the low-voltage products, the Alliance family. And those are the same great technologies. They can be paralleled up to 10 in parallel, so you can do a 48-volt, 30 kilowatt-hour, system if you so need it. And so we're looking to those. And then the other one is our Pro Alliance family, which again, same kind of architecture, right? So it's the professional alliance between the OEMs, the cell maker, and us as the pack maker. And that's the larger pack. So that's the base pack is a 52 kilowatt hour, 354 volt pack. So we can parallel those up to 10. We can series and then parallel those. So that gives us a lot of flexibility to be able to do that.
Mm.
And so those meet the needs of, a portion of the market. Now, there's always customers, and generally they tend to be the customers with a little higher volumes. When you get up to 10,000 units, demand per year, usually it makes a little more sense to do some customization. And that was where a New Flyer came in. So New Flyer's pack is a 664 volt, 110 kilowatt hour pack. So different S&P configuration of the module, but the same, it goes down the same production line as my ProLiance modules go down. So it gets assembled in the same way. It gets a different enclosure, right? But other than that, and a couple of things that were custom for New Flyer, the process by which we manufactured it is the same. And our last mile delivery is in the same boat, right? So it is a 94 kilowatt hour, 400 volt pack, same architecture. This one uses 9 modules. New Flyer uses 10. We use 6 in our base pack. So we've got this kind of flexibility to expand there. So we know that a lot of the larger customers are going to need some customization, and we're absolutely happy to do that. There's some time involved and there's some expense involved, as there will be with any of those types of programs. But we try to work with our partners to be able to minimize some of those costs as much as possible. And usually we'll go through 2 or 3 iterations. Anytime we're working with a new customer and they give us an RFQ, what we always love to do is give them 3 options, right? Here's kind of the good, better, best option, right?
Okay.
And it's usually cost, right? So this may be the lowest cost to the highest cost solution as well. Here's one which hits 80% of your needs, right? But may have the lowest NRE and investment cost. This one may be 100% of your needs, but may have the highest investment cost. I don't always know what my customers' trade-offs are going to be, right? They may have things that they say, hey, I'm willing to trade off this to get that. So if I give them a couple of options, then we can go through iterations. We'll give them 3 options and they'll say, you know what, this one works the best for us. We say, awesome. And then we can refine that and we can work through them with that. So that's kind of the way that we do that. So when we think of the product lines, that's kind of how we try to do it. We've got the architecture, which has given us the standard families of the ProAlliance and the Alliance. We've got the customs develop stuff based off of those same architectures, and then our new family, which will be coming out, in a couple of years, which I think we're gonna keep it under the ProAlliance nameplate, but we still haven't officially done that yet. So we'll do some more sexy announcements around that probably in about a year. We're still a little early to do too much around that one. But as that comes out, that'll add to our portfolio of some other stuff, and then. Of course, these are all NMC-based products. The other thing we're looking at is we're engaging with an LFP maker here in the U.S.
Okay.
So, NMC meets a lot of needs, and we kind of focused our customer base on those applications which had high energy needs rather than kind of high power needs. But there is a need for an LFP, kind of a high power, lower cost solution out there in a lot of applications. So we know there's an additional add to the portfolio. So we're engaged with a couple of LFP makers looking at how do we add that to our portfolio for coming years. So, expect to see something along those lines. We actually have access to every chemistry that's out there today. But we would expect to offer a new product in the LFP area sometime in the future as well.
Amazing. Yeah. I mean, what's so impressive is just that kind of manufacturing flexibility that you have, and all your such diverse portfolio of products is truly impressive. But I think one of the key challenges undoubtedly is going to be that manufacturing efficiency. We work with a lot of clients who are striving to kind of really crack that manufacturing efficiency, I suppose. So how do choices, John, like the 2170 versus the 4695 cells shape that manufacturing efficiency?
Huge. That's absolutely huge, right? So we spent a lot of time looking at cell form factors when we started, and this is kind of that trade-off and the negotiations you have internally as a company, right? Manufacturer would love to build one thing. If they can build one thing, they can build it perfect every time. It's like, the customers need more than one thing, though, right? So the question is, okay, how much similarities can we get together? So that was why all of our first gen applications are based off of a 2170. Right, so it allows us to do a couple of things from a cell buying standpoint. I can consolidate volumes from a bunch of manufacturers, and then I manufacture them all the same. So as we start looking at going into things like 4695s, it's going to change our process, right? So we use a wire bonding process with our 2170s today. So it's going to drive us back to a laser welding process, which we actually
Right.
started with, believe it or not. So
Right.
we,
Okay.
we started with a laser welding process early on, and just due to time to implement, we decided to go to a wire bonding process. So,
Okay.
so now as we start looking at things like 4695s and things like LFP, those are both going to need laser welding. So as we look at our next expansion capabilities, it's largely likely going to be in a laser welding type assembly process, which will allow us to, again, how do we get that flexibility to do a 21 or a 4695 cylindrical or a prismatic, LFP cell. But that's what we're trying to look at there. So when we kick off the next capacity expansion, it will likely include the tools and the capability to have the flexibility to also do these other form factors. So we'll still have the 2170 flexibility that we have, but we'll have to do something slightly different for that. And again, the tool is, again, from a complexity standpoint, minimize the amount of complexity, right? So we don't want to have, infinite variety of applications. Philosophically, we could, but the reality is 99% of what you sell will be one or two, kind of variations of it. So the idea would be let's manage the variation as best as we can to really minimize that so that we can get the best utilization out of that equipment.
Nice. Yeah. And I want to kind of go back to what you've alluded to previously about the next gen architectures by
Yeah.
that 2027, 2028. I mean, what trends, cell to pack,
Yeah.
AI optimization, modularization, what is that's driving your roadmap forward, John?
Yeah, the couple of things always driving the roadmap. Cost is always at the top of the list, right? Safety is at the top of the list. We're looking at some technologies to integrate to improve safety in our battery packs. And actually, when I think about it, I always go back to my good friend Bob Gallion's, five key technologies, right? So safety, performance, life, cost, and environment, right? So if we look at those are kind of what drive us. So
Sure.
safety first and foremost. When we go to a new form factor cell, it's going to change our functional safety. For our FUSA has to change, our functional safety plans have to change. So number one, we've got to make sure we get it right. We want to make sure that there is no potential for thermal runaway. We can manage any type of thermal runaways that happen there. So when you go to a bigger cell, you've got more energy being stored there, so there's more energy to be released. So number one, functional safety is going to be critical. And then number two is performance. How do we increase the performance, right? So how do we give customers a little bit more, whether it's a little bit more energy, again, a little more range, and then life, right? So if we look at the types of customers that we're going into here, transit buses last 12 to 15 years.
Yeah,
And
sure.
sometimes 20 years, right? So most of the applications we're going in have at least a 5 or 6 year life, and some of them as much as 15 or 20. So how do I make sure I'm managing that life? And then cost. Everybody wants to put cost to the top of the list, but realistically, if it's not safe and if it doesn't do the job and if it can't last a life, it doesn't matter what it costs. But
Yeah,
at the
exactly.
same point, once you've knocked off those first three, then cost comes to the window and say, okay, now we've got to make it affordable. And that's the thing that's going to drive, more and more adoption is going to be making it more and more affordable. So we look at those kind of things as we look at our next gen technologies, and then of course the last one, environment. How do we tie in the circular economy? How do we make sure that this thing gets properly recycled or reused at the end of its life? How do we make sure we're selecting materials that can be recycled and can be reused? So, those are the types of things that we look at when we think of that. But ultimately, it goes back to, talking to your customers, understanding what their needs are, understanding what they're trying to achieve. And that's actually one of the really, really, I think, key things that we try to do is, when my sales guys are out talking, it's give us the RFQ. But once we get it, it's like, okay, but yeah, what are you trying to achieve? Tell me that. Because we got the RFQ here, you've got all the technical specs, but what are you trying to achieve? Because often you can understand a little bit better when you sit down with your customer and really just talk to them. Because, well, this is really what we're trying to achieve. Okay. Once we understand that, now we can potentially optimize a solution, which may even be different than their requirements, right? But optimize it to achieve the goals that they're trying to achieve. So that's really what it comes down to.
I think that's the key thing, isn't it? It's okay having a roadmap developed. It's okay having
Yeah,
all this manufacturing efficiency, but ultimately, if your goals aren't in line with what the
yeah,
customer is after, then
absolutely.
you're flogging a dead horse, really, aren't you? So I think
Exactly right.
that's
Yeah,
yeah, I think that's a really, really key point. And I want to kind of zone in really on something that you mentioned there, obviously about the cost and the affordability.
yeah.
And I think that naturally lines us into the dreaded T word, right? The tariffs that's been
Oh, yeah, yeah,
imposed, which a lot of our listeners will be affected by, of course. So I'm interested to kind of get your scoop, John, really, about how you've navigated that
yeah.
environment at ABS.
I will say tariffs have been challenging for the whole industry.
Sure.
I don't expect them to be resolved anytime soon. I think it's going to be a steady state. I think uncertainty around tariffs is going to be a steady state for quite a while still. Um, we are negotiating with our two largest customers on how to manage tariffs. Because remember, when we quote these programs, we're quoting 2 or 3, sometimes 4 years out. So the problem is all the programs are quoted without these tariffs in there. So all of the costs were quoted, without these tariffs. So and our OEM partners are quoting their customers without all these tariffs. So the question is now, how do we get these and pass these
Yeah.
costs along? Because
Yeah.
again, we're all small companies. Battery pack makers are by definition small companies, right? So we can't absorb these kind of costs. And unfortunately, a lot of the materials, are coming internationally, right? So we've spent, 50 years as a world, globally sourcing things, trying to
Sure.
find the best cost sources anywhere in the world. So it changes the game, right? So we are certainly looking at U.S. sources. We are working with our foreign sources. For us, one of the biggest challenges is going to be cells, right? So we do source cells from South Korean manufacturers, which are due to tariffs. So that's going to be a huge hit. Unfortunately, for small pack makers, it's difficult to get cells in the U.S. Nearly every cell manufacturing facility in the U.S. is a joint venture with an auto OEM and a cell maker. So those
Yeah.
cells are generally not available for a small company like ABS. So the pack makers are working with the cell makers at their foreign facilities. So we just simply don't have access to those cells.
Yeah.
Um, from a larger, I will say, more strategic, vision, the bigger challenge is that, even making cells in the U.S., you're still relying on materials coming out of China. 80% of, or 70 or 80% of all the raw materials are processed in China. About
Yeah.
60% of them are actually, 50 or 60% are actually mined in China, or China has interests in the facilities in South America or in Australia. So it's really hard to get materials that don't have some fingerprint from a Chinese partner.
Yeah.
Um, and that's not going to change. It's going to take a long time for us to develop, some of the processing. And processing is probably the first step that we take here in the U.S. We can process materials here, but we've got to have the demand for it. And that's where I think we're seeing a little bit of a slowdown, largely in the automotive space. But it's permeating to the rest of the applications as well. We're past the tipping point. Electrification is happening, whether it is liked or
Whether he
not.
likes it or not.
Whether
Yeah.
you like it or
Exactly.
not, it's going to happen.
Yeah. Precisely. Yeah.
It's a viable solution for many applications, and in the types of things we do, there's a business case for it. Why do fleet owners convert their fleets to electric? Because they look at the cost of diesel and they look at the costs of electrification and they look at the 10-year life of their vehicles and say, you know what, I can get a payback in 3 years by going to electric. So they can generally get a payback relatively quick because fleet owners have high usage compared to my Silverado EV sitting outside, which I drive 40 minutes in the morning and 40 minutes in
Yeah.
the afternoon mostly.
Yeah.
A transit bus is going to operate for 8, 10, 12 hours a day. So it's going to get a lot more hours, a lot more miles. So their payback is going to be a lot better than the consumer vehicle.
Mm.
So we're definitely seeing that happening. Tariffs aren't going to go away. We're trying to figure out how to put processes in place to manage them with our customers. And right now, I would say that's about, I think, the best that we can hope for is figuring out how to manage them.
Yeah, I think a lot of people are in the same boat, really.
Yeah,
In that sense, it's a global issue, isn't it?
it
Really,
is.
not just local to ABS.
Yeah.
Do you think tariffs are delivering on intent? I mean, reshoring battery capacity, or are they just increasing capital burden and friction?
Yeah, I mean that's a very politically charged question, right?
It is. I put you on the spot with that one,
um,
John. I must say.
it goes back to my first kind of comment there is that a lot of the reason a lot of the components have been manufactured out of the States because we stopped manufacturing here, right? So if
Mm,
you don't have those resources here, it's not like you can turn a switch and suddenly start manufacturing certain components here. It takes time, it takes capital, and it takes demand. And so, we've kind of softened the demand, right? So some of the changes in policies have softened the demand a little bit, which says, okay, does it actually make sense to do that? And then it's made it more expensive to get it out. So now the question is it actually driving new manufacturing in the U.S.?
mm,
I think it's to be seen still. I think we're certainly, as a company, we are certainly looking for options in the U.S. Um, and in some cases we're finding some, in some cases we're not.
mm.
So
I mean,
I think
what do you think your take is on the US industrial policy at the moment? What's from your kind of personal perspective, being in the industry, seeing the market unfold it has.
yeah.
What is your take on that policy at the moment? How has it panned out, do you think, so far?
Um, we're still early. We're less than a year into the new administration's policies, so I think there's a lot to still be seen here. I'm certainly hopeful that it's going to work out. I would say um, the current administration, I would say, is certainly not as pro-electric as some of the previous administrations,
No.
and so some of the changes in policies are not
So
necessarily helping our industry.
no.
But maybe it's going to help in the long term bring drive more manufacturing in the U.S. It's still I think a long time before we understand that.
Yeah.
You
I
think of
think from
think of
I think
mining,
from
for
our
instance.
perspective, sorry, go
Yeah,
ahead.
I was going to say, think of mining, for instance. It takes 10 years to set up a mine anywhere in the world, right? So you best case you can set it up in 6 years. So if you said you want to start mining lithium in the U.S., and there are some new processes out there, right? Where
Yeah.
direct lithium extraction, where you can do it a little bit faster, but you're talking years still to get some of the stuff up. And then once you get the lithium out, you got to get the processing in place. And
Mm,
some of the materials, nickel and cobalt, well, just doesn't exist in the U.S. We've
yeah.
got to partner with somebody to get it in here. So, so some of these things are going to exceed the current administration's 4-year window
Yeah.
before we see impact from them.
Yeah, I mean, has the IRA funding tangibly influenced your factory expansion, hiring plans, that kind of thing? Have you felt that kind of impact from that
The
funding?
IRA has been a huge benefit for us.
Mm.
I will say that, we are, we're fortunate we qualify for the $10 per kilowatt hour for the pack manufacturing.
Yeah, which is great.
And again, as a young company starting to work towards profitability, that is really been important for us as we try to grow and move towards that one, because it takes a while, right?
Mm.
It takes a while for any company to get the profitability and to maintain there. So if you want to grow a new industry, you've got to put a certain amount of incentives in there to be able to help some of those domestic companies get to that point where they can be profitable. And so that's been a very big benefit for us. And so we certainly have included that in our business cases as we look to grow and manufacture in the U.S.
Mm. Now, I'm going to put you on the spot again here, John, because I mean, geopolitics. Yeah, how do you think geopolitics, right, is actually shaping the planning in the U.S.-China relations? Again, it's not an easy answer. I'm not just expecting a yes or a
Yeah,
no, but critical mineral access or changes into the administration.
yeah,
I mean, how much does it all weigh on your long-term vision? Because again, ABS has some big plans. You've alluded to it earlier
yeah,
in some
yeah,
previous answers.
yeah.
How does that impact you guys? And what's your thoughts there?
Well, I've done a lot of work in China in the past. I've worked with partners in China. China is one of our largest trading partners. So we need to have trade relations with them. I think is what it comes down to. We are a global environment, right? So what happens in one country is going to affect what happens in every other country. So even economically speaking, we're all intertwined. So I think that, I'd love to see the policies, open up a little bit more. I don't think there's anything, philosophically or ethically wrong with using a Chinese partner. We've got Chinese partners. We work with some great partners today. And we continue to work with some of them who are finding us, suppliers in China who have great quality, great technology at affordable costs. Mm-hmm. So, I don't think there's anything wrong with that. At the same point, as a nation, the United States needs to think about our strategic energy independence. And this is where I think that, the policy tends to be biased for strategic oil independence. When the nation thinks about strategic energy, they think about oil, right? We got strategic oil reserves. Where's our strategic battery reserve, right? And I think that's probably where we differ a little bit in policy, is that I think we need to expand our energy policy and our thinking around energy policy, not just around oil, but around other fuel sources as well. We need to think about batteries. We need to think about fuel cells. We need to think about all of these other sources, and we need to think of a portfolio of solutions, right? There's no single silver bullet. Gasoline, diesel is not a silver bullet, right? It means a lot of things, and it does what it does well, but there are other reasons to use other fuels as well. So I think our policy needs to encompass all of them, and I'm not entirely sure that it does today.
Yeah, I think that's a global issue as well. Across the pond here in the UK, in Europe. I mean, you've obviously got the Nord 2 pipeline from Russia going to Germany. The invasion of Ukraine, and all of a sudden, that problem becomes, well, we need a plan B, right? I mean, even the UK, the airport that went down had a single point of failure, a massive airport. All these flights were completely cancelled, and all of a sudden it was like, why didn't we have any kind of backup for this? Why wasn't there a plan B? And I think it's a global issue, something that we all have to address, I guess, really. So it's an interesting point, really is. So look, the road.
Geopolitics are going to continue to evolve. I think with the UK, with Europe, with China, with Southeast Asia, and as businesses, our job is to understand them as best we can and figure out how to continue serving our customers and doing it the best way we can.
Absolutely, yeah. So, looking to the road ahead, then into the future, the exciting part, I guess. So, which sectors excite you the most? I mean, we work right across that kind of battery supply chain, right? So we're right in the thick of it. But for the next sort of 3 to 5 years, is it off-road, heavy industrial, leisure craft? What is it that excites you the most, John?
Well, I kind of think of batteries and battery technology in a couple of stages, right? So you've got kind of your current gen stuff, and I think of that years 1 to 3, right? So this is stuff that is basically in production today or nearly in production today. That's the chemistries we know and love today. And then I think years kind of 3 to 5, and then years 5 to 10. So if you kind of think of these 3 milestones, we've got the cells that will be going into production 3 years from now are the cells that we know today, because it takes a couple years to validate a cell. So when we look at years 3 to 5, now we start to see some of the new things coming out, right? So I've got some great companies that I'm working with some really interesting technologies. One of them is a small company based out of Los Angeles, which is working on a technology, and the company's called Linova, but they're working on a new cathode, and it's essentially a polymer-based cathode. So it takes the NMC or it takes the LFP and it goes away. It's something you can domestically manufacture. It is as cost effective as an LFP cell, with about the performance of an LFP cell when you pair it with graphite. You can pair it with silicon or silicon graphite blend or even lithium metal, and you get similar performance as you would with those cells. That's something you can domestically manufacture. So that's probably in that 3 to 5 year range. They've got some small prototype cells. You're seeing those today. I've got some other partners I'm working with actually in your neck of the woods over in the UK. A London-based company called Gaussian. They're working on some fabulous technology using magnetic technology. So they're actually saying, how do I make those current generation batteries do more? All right. So they've got some magnetic technology that they can integrate into your packs, which will give you better charge time, better discharge time, and longer cycle life. Right. So using magnetic fields to help influence the flow of the ions within the batteries. And that's something that's going to hit in that next 1 to 3 years. And so they're getting a lot of interest from companies in a lot of varying markets all over the world. And then, of course, you look at some of the solid state manufacturers and semi-solid state manufacturers. Some of those technologies are probably in the 3 to 5 or 5 to 10 year range, right?
Bit further for that life
So
cycles, isn't it? Really, yeah.
yeah. And so when I think of the markets those are going into, if you think of aviation, for instance, well, aviation has a high need for high energy density, right? So for that one, solid state batteries, lithium sulfur technologies, those seem to make a lot of sense. They're using high energy current generation cells today, but to get the efficiency and the cost, and those will generally have a lower cycle life requirement than some of the things that I do, right? So when you look at the aviation industry, I think you'll see some of those technologies starting to move into that space.
Yeah.
Marine has always been an exciting industry for me. I've been really fortunate to have done some stuff, and I've kind of been at the adjacencies of marine for a long time, right? So I did some work years ago when I was with Exalt Energy, when Norway was still starting to ramp up all of the stuff they were doing there, worked with
Yeah,
DNVGL,
yeah,
worked with Lloyd's of London, worked
yeah.
with the U.S. Coast Guard on some programs. Really exciting stuff. So we're seeing that here today, and we're starting to see it in leisure craft, right? Which is a new area. So typically, I would say initially we saw electrification in things like barges and things like ferries, right? Ferries is a great application to electrify. You can generally go from one port to the other, and you can charge on either end. So we saw a lot of that in
Sure.
Europe. You're seeing a lot of that even in the U.S. You're seeing some in Boston. You're seeing some up in Seattle. And so those things were always great. But again, you're talking about floating grid batteries at that point, right? Megawatt hour size systems. So you saw a couple of companies working on some leisure craft boats. What if I can take a boat and put on 100 kilowatt hours and just tour around a lake all day? And so you're starting to see more and more of that in the U.S. here. There's actually a new organization here in Michigan that has been working all up and down the coast of Michigan, working at electrifying, small pleasure boats. So
Okay.
we're seeing a lot of that happening here, even in the U.S. And again, you think about it. If you're sitting out there on a boat all day, well, why do you want to run that diesel or gas engine when you can sit there on electric, right?
Exactly. Yeah,
If
exactly
you
that.
can do it without the emissions, without the oil, without having to worry about anything, and still do what you want to do all day and get back into the dock,
Why wouldn't
there's
you?
still some challenges to overcome.
Of course.
So we're seeing a lot of that. I really like robotics. That's the other area that you didn't mention. But I think
Mm.
robotics is really exciting right now. We're really at an interesting point where we're seeing a lot of autonomous robotics starting to go from small food delivery robots in the big cities to warehouse robots. You got a couple of companies that are working on things like humanoid robots. For you've got things for space exploration. So there's a lot of really interesting technologies. We try to focus on, again, things that are near to production.
Yeah.
Again, one of our, I'll call it keys to success, is that we don't do a ton of R&D work. We kind of wait for some of these technologies to get closer to productionization before we engage with them. But there's a lot of really fun stuff happening out there in the world right now, and I can't wait to see some of the new stuff that's coming around. I'm always excited to see how the technology evolves, and people get new ideas when they see new things come together. It's like, hey, this is great. If we could do this and that and the other, then we get this, right? So
Yeah, absolutely. It's such a fascinating market to be in,
yeah,
right? And I think it's such a diverse,
oh
kind
yeah,
of thing that we can look at. It's
yeah.
so exciting to see what's coming next. But so look, your 10-year view, what will need to change the most? Do you reckon? Is it chemistries? You mentioned architectures, of
Yeah,
course, as well. Autonomy integration. Obviously, you mentioned the autonomous
yeah.
robots and things like that. Where will ABS play a leadership role in amongst all this? What's going to have to change that kind of 10-year
Yeah,
view?
if you look at the 10-year window, again, obviously we align with the Komatsu vision for CO2 reduction. So again, working with applications, trying to drive that CO2 reduction in there. But we continue to drive ultimately, improving performance, reducing cost. I think that's where one of the biggest challenges that we face today is still in the cost infrastructure. There is still, again, it's that, and again, if you think about it, liquid fuels, gasoline and diesel is somewhere around 10,000 watt hours per kilogram, right? And
Mm.
so we're sitting with lithium ion around, 180 watt hours per kilogram at the cell level, right? Or 280 watt hours per kilogram for some of the better technologies. So we're just barely breaking 300. So we're not even, 1/10 of the energy capacity of liquid fuels. So increasing the energy density, trying to drive that up at the same time, getting the cost down so it's a more affordable solution, right? So you've got to be able to achieve the mission profile, whether that's driving you to work or whether that's running a piece of construction equipment all day long. So you've got to get that increased. You've got to get the cost down to the point where it's also an affordable solution. We still see a lot of, if you look at the consumer vehicle space, we still see a lot of $80,000 to $100,000, EVs, which is great, but the market is only so big, right? You still need a $20,000, introductory level EV.
Yeah.
You still need something in the sub $30,000 range for consumers. So, I think that there's work to do. We've got to continue to drive energy density up. We've got to drive costs down, and we've got to, make it safer, right? And that's one of the reasons I like some of the technologies that I'm working with is safety is going to be critical because, if we can get to the point where we have a truly inherently safe battery, which one of the other companies I work with is called Soteria Battery Innovation Group, and they're working on technologies that you can integrate into the cell itself, right? So to make that inherently safe cell, much like the Lynova cell I mentioned. Both of those technologies have the potential to create something that's inherently safe. If you create that inherently safe cell, then what that means to me as a pack maker, now I look at everything I do and I can say, what do I not have to do now? Right? Because if you think of it, the job of a battery pack maker, whether you're a vehicle OEM or whether you're a company like ABS, our entire job is to make the cell safe and make it meet the mission profile. But if you now said, okay, the cell itself is inherently safe, what functional safety aspects can I take out of the pack, right? So that's cost, that's weight, that's probably volume and size, to make it more effective. So as I look at the future, those are the types of things I'd like to see. I'd like to see us get to that inherently safe cell. Let's get to more cell to back technologies. I think you'll see more and more of those. It's a little more difficult with a pouch cell. It's a little more difficult with a cylindrical 2170 cell. But I think there's other things coming. I think you're going to see some other form factors. I've been watching a couple of the cell makers out there working on some kind of unique form factors, which I think will get introduced in the next 5 years or so, which may help from a packaging standpoint as well. So I think there's a lot of things that are always in play, and that's really the beautiful thing about batteries, right? Batteries have been constantly evolving for 150 years, really, right? So it's not stopped. If you think about it, in 1991, when Sony introduced that first cell, it was I think the LCO chemistry. It was about 70 or 80 watt hours per kilogram, right? So we're sitting here today at 300 watt hours per kilogram and above, right? So if you go to some of the semi-solid states, you're sitting at 350, 450, 500 watt hours per kilogram. And that's been in a relatively short period of time. You're looking at 30-ish years or so. So
look how far we've come in that such a short space. It's what a leap from the 90s to here. It's phenomenal, really.
And I mean, just look at the costs, right? From 2010 to 2020, the costs went from $1,200, $1,400 a kilowatt hour, down to a couple $100 a kilowatt hour. Sitting here today with the Bloomberg New Energy Finance telling us that we're sitting at like whatever it was, 134 a kilowatt hour at the pack level.
This is what makes me optimistic, John, about the future, right? Because I think the big question often around this industry is, look, is it achievable? Can we get, EVs and batteries which are actually affordable to customers and consumers? And looking back at the history from where we were back in the 90s with Sony to where we are now, operating in the megawatts that we are operating in, that really does make me hopeful for the future.
Absolutely.
Guys like yourself working, behind the scenes, doing the good work. It really makes me hopeful of what's to come.
Oh, absolutely. No, it's an exciting time. I would say there's probably never been a more exciting time to be in the battery industry or the electrification industry, right? The technology is changing so quickly and so much, and so many new applications. If you think about everything that battery technology has enabled, right, since they were first introduced in 1990 from Sony, everything we do today, from our cell phones, to our wireless technology that we use, it's all been battery powered, right? We have made technology mobile, and so it's going to continue to evolve. So the question is, where can it go next? There was some great work done by ARPA-E. I participated in a couple of our ARPA-E programs years ago, and there was one area that I still keep my eye on, which is, they were trying to figure out, how do we take and make a structural component into a battery. So think about making a body panel a battery for a car, right? So now you take the volume away, right? Because now there's no additional space for the battery. So if you could do this and think about maybe a solid state battery, right? If you were to form that, it's now starting to become viable, right? So things like that, 3D printed batteries, you see some great work going on in some of that kind of stuff. So these just so much exciting technologies. And you just look at the chemistry evolution. You're seeing, General Motors announced a lithium, manganese rich LMR. So that's going to potentially come out there and offset some of the LFP demand. So you're going to see all these kind of technologies which have been in development for a while starting to get exercised and more and more.
Absolutely, come to fruition and see unfold, and then that gives credence to the next step as well, the next chapter. So you and I could be here the next 5 years, John, talking about the next chapter, the next 10 years.
Absolutely. So, I mean, 10 years from now, you're going to see a whole new set of chemistries, a whole new set of technologies. I won't even try to guess what they're going to be, but I think you're going to see, you're going to see a whole evolution. You'll see some of the same stuff we're doing today, but you'll see a whole evolution of things that may go off even in other directions. So there's a lot of neat stuff happening in the battery industry. There's some just phenomenal research organizations out there globally working on stuff, and it's going to continue to evolve, and it's going to continue to power the world.
So I guess then, for these battery startup companies with these new chemistries that are just finding their feet, that are just trying to get a bit of investment. I mean, look, ABS, you guys have been there, you've done that, you've navigated through COVID, you've had all kinds of hurdles to jump over. What advice would you give to those battery startup companies who are just starting out, very similar to yourself back in 2018? What advice would you give?
I think one of the most important things that we were able to do is we were able to maintain focus. Right. So I think that, one of the biggest challenges for a young startup is you get pulled in 1,000 directions. Right. Your VC investors say, hey, I just talked to this guy and he says this would be great. You should go into this application. And then you get this customer says, hey, I could use your thing here. And I think that's the biggest challenge that so many young startups get struggling with, is that they get pulled in so many directions. Like, yeah, we could work there and we could work there and we could work here. We can work on all these things.
Where's the focus?
And the problem is, you're 12 people. Right. So it's like, you pick one. So I love to say this, pick one thing and be the best in the world at it. If you can do that. And then number two is, understand your customer, understand how your technology benefits the customer. Right. So I think that those are the two things. Be focused, understand the customer and how your technology benefits the customer. Those are really the key things here. You got to have a great, financial partner. And there's a lot of great organizations out there that are providing financial support. I think having a long-term partner, and I think there's two, stages of growth in a startup company, right? You go through the kind of the angel investor stage, and then the VC stage, and then kind of the large investor stage. But you got to find those long-term investors, those large investors willing to invest for the long term and help support your vision and your growth. Because I think if the investors aren't aligned with your vision, then that's going to drive that division of labor and division of activity. So being able to align some of those things, and it's not always easy. It's definitely not easy. I'll say if you get a chance, check out some of the work that Dr. Holly Cheeseman has been working on LinkedIn. He's published a bunch of kind of short articles about it. He's interviewed 150 startup folks. We're actually going to do a panel at the battery show on this very topic, right? So
amazing. Look forward to it.
How do you avoid that valley of death? Because I think it's critical for so many young companies. You get to that point, you get a great technology, you get some early adoption, and then what do you do to make sure you don't fall off into that valley? How do you extend and jump over that valley and live through it?
Well, look, we'll be fascinated to listen to that and to join you at the RE show. So, no, listen, John, I could sit and talk to you all day. Truly, I could. We've just gone over the hour mark, but I really appreciate the time, John. It's been fascinating to listen to the journey of ABS. What a wonderful 6-7 years it's been so far, and really look forward to seeing what the future has in store for you as well.
Yeah, next 7 years are going to be just as exciting, I'm sure.
Absolutely. Well, listen, awesome. John, really thanks again for your time, and look forward to catching you again soon.
Thanks, Matthew. It's been a real pleasure. I appreciate it.
All the best. Cheers, guys. Thanks for listening. Bye-bye.